Hello. The topic that we are going to study today is general aspect of database security. So we're going to consider why database security is important. And we'll look at the properties of database security and some class of categorization of attackers and types of attack and threats and some other issues. All right, I'm going to make this a quick presentation. The reason is that you can understand by reading the text that I provide to you. Why database security? As you may see, that database is the repository of data sets, and security is important if that repository contains sensitive data. So generally we can think of three properties of database security, and each of these will be discussed in this way. Confidentiality. What does that mean? It means privacy or ability to control and restrict access once it is accessed, once it is allowed, then only authorized individuals should view at the level permitted by the policy. So confidentiality is usually described as a policy, and policy is enforced when a user is accessing to the database. Many cases, how can we achieve confidentiality? We can do it in general by access control or authentication. At some situation, we can do the encryption, particularly if it is a privacy issues. Then we can think of encryption technologies. Integrity. What is integrity? So accuracy of data, and data reflecting the real world preserves the integrity. So information is accurate and reliable and has not been subtly changed, tampered with by an unauthorized party. Before data is accessed, we assume that is the preserve integrity. And after the access by users, data should still preserve the integrity. That is the characteristics of this issue. Okay, so in order to preserve integrity, then we need to always ensure the privileges of user access. And meanwhile, we also need to make sure that non-repudiation, the origin of any action on the system, can be verified and associated with a user. It shouldn't be repudiated if the authorized user is considered. and also the authentication is important. Availability is a portion of time a system is in a functional conditions, so should be available. The permanent and tight, secure protection of data is possible if there is no service. If data is unavailable, then it is insecure, right? But it is not what we want to achieve. We want to achieve in a way that it should be confidentiality should be preserved and integrity as well, while data is still available. All right. Attackers can be categorized in this way. Can be some attackers are intrude from outside, or some attackers simply insider. Some attackers are administrator by themselves. Administrator and insider both are insider, but administrator has almost all the powerful privileges. Therefore, this is really dangerous, right? In a case that clouding server, as you subscribe to the cloud computer, not the infrastructure, but not service as infrastructure, but service as, for example, software, then software is controlled by an administrator. And when you do some outcome of the software usages may remain in the system, then can be controlled, it can be managed by the administrator, which we do not know, which we do not want them to access the outcome of our software usages. But that is still possible, right? How can we protect any resources, any data from administrators accessing? That is the big issue. One way that we can preserve is that if we encrypt it, okay, encrypt the data that we create from a software, then that is some type of a protection. But as you may understand, it is not really 100% protection of our data from administrators' access. Some attacks is direct, some indirect. Direct attacks may be successful only if a database does not contain any protection mechanism. Then you can attack it directly. Indirectly, information from or about the target can be received through other intermediate objects. For example, if there is a proxy server, and let's say here we have that database, okay, and we trust the proxy server, okay, proxy server, so they trust each other. But there is a usual trusted user, so we allow them to access through the proxy server all the way back our database. But somehow, if there is any spoof attack. So some other users in between, then this guy act as if a trusted user, then, and also this guy access through the proxy server, then my database simply trust any access through this proxy server. In this case, that is indirect attack. And passive attack and active attack. Attacker is interested in the data present in the database. Any data in the database is they are interested, and there is passive attack. So static leakages, linkage leakages, and dynamic leakages are possible. On the other hand, the active attack is the actual data values are modified, and they are more problematic than passive attacks because they may mislead a user. Why? Because the modification is the action by this active attack. Okay. And identity theft, that is an ongoing problem, right? In many cases, that happens. To our database exports, SQL attack is the big issue, right? There are some cases in Bombay. I wanted to read this slide. And also JavaScript attack. If the JavaScript is embedded in web-based database, web-based server, then somehow there's a server-side JavaScript and client-side JavaScripts are available. At the server side, there's some privacy and security sensitive data available with some function to be defined. And this information is available in a way that at the client side in HTML, there we know there is a JavaScript, and it should be executed. All right. So the attacker can attack the client side and simply adding some function, not only this given, but this part is added to the client side, and therefore we can access sensitive data if those data are available from the server side. Okay. So through the AJAX, AJAX security is another type of threats I described. There is some issues at the server side and client side. So real issue is that the attacker can obfuscate JavaScript code and modify it, and that code, the modified code, can steal session cookies. Usually, the AJAX code available at the client side has cookies that holds a login name, password, and so on and so forth, so that this JavaScript can go back to the server and access the data automatically. How come it is possible? Is because it has valuable data in the cookies, and cookies can be accessed by the code. Okay, that is a typical attack. Cross-site scripting, that is and doable, and also that is another type of threats. Cross-site script attack is very similar to JavaScript attack. The case of one typical case occurred in 2010 is the attacker Nesta. That attacker shows a malicious message. If a user moves the mouse over that message, the message appears in the client browser, then malicious JavaScript pops up. Okay. So database security is important, and why? Because database contains a lot of valuable, meaningful data sets that we want to put our trust in, compared to file systems, right? This is really good. So every organization must be having its own security policy. Security policy needs to be defined and should be enforced. Strong security policy must contain well-defined security features. The stronger, the better security, but little less availability of data. That is the issue, right? Security policy may preserve or may ensure security itself, but at the same time, it may lower the value of the degree of data availability. We will have a separate module called access control. About 10 years ago, I contributed the new ideas of access control to the cybersecurity community, and it was published in the world-class journal, IEEE Transactions. So I'm not sure we're going to look at it, but the idea will be delivered to you when it comes to that module. Okay. Here, the module for today, I'm going to give you a brief idea of access control. What is access control? Access control is to ensure all the communications with the database and other system objects or according to the policy and control defined. So actually, what it does is that we have database. Okay, we have database, and we have a user. When user comes into our system, the first thing they need to do is to get the authentication. So the server say, hey, you're okay, but another control needs to be enforced depending upon the data that this guy wants. Okay, if this guy wants this piece of data, then it is okay, right? But another piece of data, then it is not okay. Not okay. How can we control this? So depending upon the data piece, we need to control the user access, and also not only the type of this data characteristics, but another thing is that the action of this request. For example, this guy simply wants to see it, or this guy wants to modify it, or this guy wants to do some other actions. So they are all related. They are all the factors, whether we allow him to do or disallow. Okay, that is the major concern of access control. Once policy is made, then the situation is this: there's tons of policies are defined, and some policies are cascaded, one policy after another policy. Some policy, maybe there is some a little bit of a conflict, and because we do not need to describe whole features of the policies, policy needs to be atomic. Policies better to be atomic, but when it comes to some situation, those atomic policies can be combined together to make a complex policies. So inferencing is needed. Okay, so a lot depending upon inference rule, depending upon security policy, if initially we have this type of policy is given, but in some situation we may have another type of policies by inferencing, okay, from here to there. Authentication and identifications. These two issues are not unique in database, but authorization is unique in database. Usually, operating system level of access control, we do not really care about authorization. But authentication and identifications are enough. So this issue is very common in many other security management. Accountability and auditing and encryption. In Oracle, we can encrypt column level, database level, instance level, and column level is a field level, right? Instance level is a row level. For example, if we think of a table, Okay, so we have columns and rows, right? So this is a username, and this is date of birth, and this is a salary. Then we can encrypt entire row. Okay, and few of those rows, all the rest not necessary. Or we may encrypt only salary, only some sensitive columns, or entire tables, entire databases. So there is a multi-level of encryption mechanism is available in Oracle. All right. I described the responsibilities of database administrators. So I wanted to read DBA's responsibilities here and there. Database security issues that we can think as a cryptography. This is encryption, access control, particularly using authorization. So we're going to practice these two issues in Oracle. And steganography is also something that we can consider. What it does is that some data can be hidden behind some other data. Okay, so cryptographies, there's encryption algorithms and some other techniques are considered. Steganography, also various techniques available. The idea there is data is embedded in the least significant bits of its pixel values. If it is the least significant bits, then without changing the size of data, because we are using least significant bits, instead of carrying over least significant bits, then we can plug that portion some images, for example. Okay, so that is a steganography. And access control, we'll look at this in a separate module, as I said. Okay. Authorization policies are hierarchically designed. Therefore, we can think more specialized authorization models and more generalized authorization models. Those are all possible, but authorization mechanism has been developed and implemented in Oracle in a very, very reliable way. So we will look at that using Oracle. All right. In Oracle, to implement authorization model, we can use SQL, and SQL has some mechanism called the trigger. Okay, when user access my database, so we have here user pose on SQL statements so that my database needs to evaluate their request. Depending upon the request, if it wants to touch sensitive data, because we already defined some policy using, for example, trigger, then without letting him know in behind this DBMS trigger some policy. That policy needs to be inferenced, and therefore finally we have some decisions. So depending upon this decision, we can provide the proper answer to the user. Okay, so for example, this guy wants to access some sensitive data as a manager role, then this guy can access those sensitive data for the employees who are reporting to himself. But he cannot access any data belonging to someone else who is not under him. That type of things are dynamically, adaptively, automatically controlled. That mechanism is possible in Oracle. All right. So this is a short lecture about database security. What we will do is that in another module we will look at separate module for access control, and then we will go back to the real Oracle practice and lab, and from there hopefully you can get some skills, and finally you can do the project. All right, I'll see you next.